Okay, so next we start with the next portion, test 9.1D, question B, all these questions. Okay, class 10 maths, exercise 9.1. We'll start with the 13. In this video 4, we'll do the 13 and the 14. And the next video, 15 and 16. So let us start with B13. Let me read the question. As observed from the top of a 75-meter high lighthouse, from the sea level, the angles of depression of two ships are 30 degree and 45 degree. If one ship is exactly behind the other and on the same side of the lighthouse, find the distance between the two ships. So here's a lighthouse, means a tower-like structure in the middle of the sea is called a lighthouse, 75 meter tall, top A and bottom B. The person is on the top of the lighthouse, right? And this is the water level. Now lighthouse is a structure from where you can give directions to the seas or to the ships in the seas, okay? So the person is here and there's a ship here in the sea, let us say, another ship. And both these ships, C and D, they are on the same side of the lighthouse. Therefore, we drew it on both C and D on the left side, right? Or you can also draw both on the right side also. But they should be on the same side because the question says so. So he look at the ship C. So join his eye to where he's looking. His object is the ship C. So that line is called line of sight. We learned that in the first video. Then draw a horizontal line through his eye because his eye is A. And you know this angle here formed between the horizontal and his line of sight. We know this is called angle of depression because he is looking at the object now below his eye level. So therefore depression. From the same position, he also look at the ship D. So join his eye to where he's looking, which is D, line of sight, and the horizontal line here. It is making 30 degree. This small angle here. Okay, so let us mark this one X and the water level here. Let us join it. The lighthouse will be 90 degree to the water level. Okay, so since these two lines are parallel, this 30 degree will be transferred here and will be equal because they are alternate angle. Likewise, this also alternate. Both of these are equal 45 degree each. Let us write down here in the figure. Okay, in the figure, AB is equal to 75 meter. This is the height of the lighthouse. Okay, height of the lighthouse. Then here's CD. Okay, the distance between the two ships is this one, CD, and the question is asking us this distance, question mark. Equal to question mark is the distance between the two ships and the angles of depression. Okay, right along with the video, okay? Angles of depression here. The first one, angle XAC equal to this angle SCB, because they are alternate angles, 45 degree. Then angle XAD, this one, equal to angle ADB equal to 30 degree. So with this information, we have to find this CD, distance between the two ships. Let's take this first small right triangle. So in right triangle ABC, here in the right triangle ABC, here we want to find BC because that's related to the distance between the two ships. So unknown, we preferably put it on the numerator, and a known side here. We know one side is known, so very easy to find BC. So that is adjacent by opposite. And we know the name of that ratio is cot, so that is 45 degree. So next here BC, and then don't shift that. Then if you shift this 75 from denominator, okay, before you shift, one more step, cot 45 is 1. We know from our tables in our previous exercises. So BC will be equal to, here don't shift that, and denominator shift means it will go up and multiply 1. So 75 ones are 75 meter. So this is your distance for BC. Likewise, advantage is that this AB is also the common side to the bigger triangle, means AB belongs to ABC triangle, as well as ABD. So you can use that AB again to find BD, just like we did here. One side is known, one angle is known, then we can find BC. Likewise here in the big triangle ABD, one side AB is 75 known, one angle 30 degree known, and we can find BD. We know that in the beginning of the video we discussed. So BD we can find, BC just now, and you do that BD minus BC, BD minus BC, and you're going to get CD, the one we're searching, distance between the two ships. So that's how we're going to do it. So next here, in right triangle ABD, the bigger one, we want to find BD, so write that on the numerator, and the given side is AB. Here, BD by AB. Again, adjacent by opposite, so again, cot. And this time it is 30 degree. So here next, that implies BD by AB is 75 meter very clearly, and cot 30 is root 3, right? So we write here, BD is equal to 75, shift means it will go to the numerator and multiply root 3. So becomes 75 root 3 meter along with the meter. So we got both of these here, 1 and 2. So we're ready to find the distance between the two ships. So here you can write here, therefore, CD, the value we are searching for, is nothing but the full line BD minus this BC here. So BD just now we got it as 75 root 3 meter minus here BC, we can see here, is 75 meter. So we can write here at the back the reason for that, since using equations 1 and 2. Here 1, from there you got BC 75, and from 2 you got BD 75 root 3. So common 75 can be taken out of the bracket. Then inside the bracket will be root 3 minus 75 ones are 75. Then meter common can go behind outside the bracket common. So your answer is here you can write distance between the two ships. Okay, the distance between the two ships, which is represented by CD, is equal to here 75 into root 3 minus 1 meter. So that is our first answer, right? So here next we'll go to B13. So here B14. Now B14 looks complicated and long, okay, but it is quite simple if you think carefully. So listen carefully to the video. So here let me read the question for us. A 1.2 meter tall girl spots a balloon moving with the wind in a horizontal line at a height of 88.2 meter from the ground. The angles of elevation of the balloon from the eyes of the girl at any instant is 60 degree. After some time, the angle of elevation reduces to 30 degree. Okay. Find the distance traveled by the balloon during this interval. So there is a girl whose height very clearly mentioned here. The girl's height is mentioned as here 1.2 meter. Let us say this is the girl's height. A is the top of the girl and B is the total height, AB. A is the eye, that means 1.2 meter. So her eye is A and she looks at the balloon. Let us say this is the balloon. And so draw a horizontal line through her eye. So since she's looking the balloon above her eye level, that's why they're calling it as elevation. So let us say, clearly the question mentions this one as 60 degree, okay? 60 degree, mentions this one as 60 degree. Okay, let me just slightly draw it this way. Okay, this way, 60 degree. So this one is here, this is the balloon. So she looks at that and this is 60 degree. Very clearly mentioned. Then the balloon seems to have moved away. Even though the question did not tell us that the balloon has moved away, we can easily understand because after some time she looked at the balloon which is moving horizontally. That means this balloon is not moving up or down but same level from the height with the ground, and then it begins to reach a new point and the information says the angle of elevation has changed to, this is 60, has changed to 30, reduced, that means. Then unless the balloon is moving away, how will the angle decrease to 30? From there, we come to know that the balloon is moving horizontally away from the girdle, right? Now the question says the height of the balloon from the ground. Here, this ground level, this height is nothing but 88.2 meter. So let us join this to the ground, make 90 degree, and then join this horizontal line, again 90 degree, and then join this to the base, again 90 degree. So this is the situation. Let us complete it. C, D, E, here F, and G here. Let us say H. So the question is saying, find the distance that the balloon has moved away, which is G, F. We have to find that. Okay, so let us do this. In the figure, here, let us just write down first what we want. Then GF is equal to question mark is distance traveled. Okay, distance traveled by the balloon. Distance traveled by the balloon that we need to find. Then here, let me write this one and I'll explain it. AB equal to HC. All these three will be equal to ED. Okay, will be equal because you see here, AB equal to HC equal to ED because you know this one is here equal to 1.2 meter. This represent the height, H-E-I-G-H-T, height of the girdle. I'll explain it to you. The reason for this is because we know opposite sides of a rectangle are always equal to each other. Let us put this one as a question 1. What do we mean by that? You see here ABCH is a rectangle and AB and HC are opposite sides, so they will be equal. AB and HC. Also, not that only, ABDE is also rectangle, so AB and DE are opposite sides and they will be equal. So all these three will as well be equal. So since AB is already found out to be 1.2, the three values therefore will be 1.2 meter because we know opposite sides of a rectangle are equal. From there we understand that these three values will be equal. Okay. Now one more thing here, I'll write here GC will be equal to, again, FD equal to 88.2 meter. This is the height of the balloon. Okay, height of the balloon above the ground, if you want to put, or that is enough. How do you know these two are equal? Because the question says the balloon was moving horizontally, means horizontally above the ground means it is not going higher above ground or below also, always maintaining the same distance above the ground. So their height, balloon was at G, now it is at F, their height will be unchanging because they are moving, the balloon is moving in a horizontal manner. Okay, now there are two angles of elevation, so let us mention that. So here, angles of elevation. First, she look at the first position of the balloon, and the angle of elevation at that point of time was angle GAH, and she found it to be 60 degrees, the question says. After some time, it moved to F, and the elevation has changed to FAE is equal to 30 degrees. So that is the information given to us. So with this information, we're going to have to find GF. Okay, so directly let us move to this, and I'll explain along the way why this is so. So here, we want to find FE. This is important. Now FE here is equal to FD minus ED. That all of you can understand. See, FE is full line FD minus ED. So why did we do that? We'll find later on the reason, but FD is given. That's why it's easy, 88.2 meter minus ED here in equation number 1 here. Let us put this one as equation number 2, by the way. ED is 1.2, so we write here 1.2 meter. And we write here, since using equations 1 and also 2. FD is coming from equation number, FD is coming from here, FD here from equation number 2, and then ED is coming from equation number 1 here. So that's the reason. Okay, so when we subtract these two, we will get 87 meter. 88.2 minus 1.2 will give you, subtract 0.78. So this one here, 87.0 means 87 only. But we know here, right here, we can do it. Here we can just do it below here. But here, very clearly here, you can see here that these two are equal again. So you can write here, GH is equal to FE. The reason for this is because opposite sides of a rectangle are equal. You know this by now, that this property GHEF is a rectangle, right? So GH and FE are opposite sides, so they are equal. So if that is established, then we can write here GH and FE, both of which are equal, will therefore be equal to 87 meter, because FE is already 87. Well, we are interested in both, that's why we did that. Question number 3. We need this FE and GH to find this distance GF. Soon you will find out why we are doing this. So here, why did we find FE? Let us take that in right triangle. In right triangle, AEF. Now we know FE, one side and one angle is there, 30. So we can easily find AE. So we're trying to find AE by using this right triangle. Remember that, okay? So put that on a numerator by FE is the known side denominator. Then that is here adjacent by opposite, again, that is cot. Angle is 30 degree. So here, AE by here FE, right? FE here, you see here, 87. So we're taking advantage of this. One side of the triangle AEF is known now, FE. Cot 30 is root 3, so we just put it there. And we write your reason for changing this is using equation number 3. Here FE is coming from equation number 3. That's what we mean to say. So here we get here AE equal to 87 root 3 meter. Because if you shift this, it will go up, right? So that is your first one. AE found out. Then minus, you see, AE minus, suppose you did AH. Then will you get this one? AE minus AH will give HE, which is actually same as GF, because they are opposite sides of the same rectangle here. So that means if you find HE, that means it's as good as finding the distance traveled by the balloon. So that's what we're going to do. So let us take the other right triangle. So here, in the right triangle, the other one, GAH or AHG, whatever, AHG or GAH, you want to find AH. Just as you see here, AE minus AH will give you the HE, which is the distance traveled by balloon. So GAH, you want AH, so we write that AH divided by the given side is GH. You see here, GH is already known, 87. AH by GH. That's why we were doing not only FE, but GH also. Because we know, we can foresee that we're going to need that in the triangle GAH to find out AH. So AH adjacent by opposite is again cot. So we write there cot, and the angle this time is 60 degree. Let's do slowly. So as we go on doing here, and come here, let us say. So here AH, we write here AH as it is. We don't know yet that one. And GH is very clearly given here. That's why we're making use of it. Is equal to cot 60 degrees, we know 1 by root 3. And we can write here since using equation number 3 again. See here. GH equal to 87. Replaced GH because of that. So here, once we are done with that, next here, don't move AH, that's what we're trying to find out. And if you shift this denominator 87, it will go up and multiply 1. So 87 by root 3 meter is what we'll get. Now we know by now, when you have an irrational number in the denominator, we have to remove the irrational sign. We know very well how to do that now. So let us just, how do? We multiply by the same irrational number up and down. Root 3, then root 3, root 2, then root 2, like that we multiply. So this 87 into root 3 is 87 root 3, these two multiply. And we know very well, root 3 multiplied to root 3 means the root will be removed. So we have removed the root sign, irrational sign, and meter still is there. So 3 1s are 3, 3 2s are 6, 2 in hand, 3 9s are 27. So this is 29 root 3 meter, the equation number. Following the last one, 5. So now very easy now. Therefore, we will write here, you see here, HE, okay, GAF. That's what we're trying to find out. GF, or we can just go a little bit to the corner so we have space on the right side. GF, the distance traveled by the balloon, which we're trying to find out. See here, distance traveled. This is what the question is asking. It's actually equal to HE. Let us establish that first. And we know why this is, because we know opposite sides of a rectangle are always equal to each other. So we write that. So if that is established, then we can write here GF is equal to HE. And HE, if you observe carefully, we can change it to AE minus AH. AE minus AH. Now we are very confident about this because we have both the value AE in equation number 4 and AH in equation number 5 just now. So AE 87 root 3 meter minus AH 29 root 3 meter. We write that as it is, and we write here since using equations 4 and 5. Then here 87 root 3 minus 29 root 3 is as good as 87 minus 29, plus and minus. So 8 subtract, then 7 minus 2, 5. Bigger number plus, so here also plus. So this is 58 root 3 meter, right? So it's something like 87x minus 29x will be 58, right? 87 minus 29, so 58. Therefore, finally, we can write our answer. So here, you can write your answer like this. Let's write the same statement. Therefore, distance traveled by the balloon, comma, GF, that's what we put in the beginning, is equal to, this one you will write in the last step, okay, behind this. It will be equal to, just now we got it as 58 root 3 meter here, as we can see. I hope you have understood, okay?